So I'll introduce myself again. My name is Stuart Lewis. I'm a student at Newcastle University on the third year of my game design and simulations course. I'm here today as an instructor for Carpentries. And today we will be looking at using lists in Python, using loops to iterate through those lists, using this with what we've learned yesterday about plotting graphs to plot graphs from multiple files. And then we'll look at using conditional if statements, and then we'll look at functions used to simplify our code. So I'll start by sharing my screen. So can everyone see this?
Yes.
All right, all good. So I'll start. I'm going to be working on Jupyter Hub, the same as Martin was yesterday. So I'll start by creating a new Python notebook. And I'll call this one Python 2. So to begin with, we're going to be learning about lists. So in the previous episode, we looked at a single file and we plotted graphs for it, and we saw, I believe, some peculiar information, some strange trends in the data. But that's only one of the files we have. If I go to the data, we'll see we have 12. So if we want to go through all 12 of those files, it's not very practical to write that code the same 12 times. So the first thing we look at are lists. Now, unlike NumPy, these are built into Python. So I don't need to say import anything. So we'll start by defining our list. So I say odds is equal to, and we always define a Python list using square brackets. So everything inside the square brackets is part of our list. So now I want 1, 3, 5, and 7. And you see we delimit them. Each value is separated by a comma. You can add as many or as few spaces as you can. Normally 1 is added just to make it clear. So then we can print our lists. And there we go. Our odds are 1, 3, 5, and 7. So in order to access the values of the list, it's very similar to NumPy. We use the square brackets again to index the list. So if I want to print the first element, I would say odds 0, because remember, Python indexes from 0. And if I then want the last element, this list is 4 elements long, and since it indexes from 0, we'll be going from 0, 1, 2, 3. So I want element 3. And another way of accessing the last element is by using negative numbers. So if I say odds -1, that'll be the same in this case as saying odds 3. And so you can see we have the first element is 1, the last element is 7, and the negative first element is also 7. If I say -2, that will give us 5, the second to last element. So we don't have to just use numbers in list. We can also put strings. So if I have a list of names, so we have Curie, Darwin, and Turing. Then we can say names is names, and it works just fine. But you'll notice I put a typo here. This was intentional for this, because we can just edit it here, but we don't have to edit it at the start. We can edit it later. So what I can do is I can say names1, which is the position of Darwin, and I can say that is equal to Darwin without a typo. So now if I print names again, you can see it's been fixed. So one thing to take note of is this doesn't work with strings. So we've looked earlier that we can do a similar thing with strings. We can say print print hello world, and we can index 0, and that'll give us H. And we can also index -1, that'll give us D. But we can't say, if we put this in a variable, so my string is equal to hello world, and if I want to say my string 0 is now a lowercase h, it doesn't let us. We get a type error, which tells us, so a string object does not support item assignment. It simply means we can't change it. It's what we call immutable. So if we create a new list, we'll call it salsa, and we'll put in some food. So we'll have some peppers, onions, cilantro, and tomatoes. So if I create another variable and say my salsa is equal to salsa, and now I change the original to hot peppers, what do you think will happen? Will my salsa be the same as it originally was, or will it have been changed as well? Feel free to shout out if you have an answer.
I think it won't change.
Okay. So we can find out if we print the new list and we print out my salsa, we can see it actually has been changed. And the reason is, when we store a list like this, we're actually storing a pointer to the original list. So because a list is what we call mutable, we can change the values inside it without changing the entire list. So it still refers to the same list. When we store this, we're storing actually the exact same list. If I was to change my salsa to a different variable afterwards, so my salsa is some other list, then they would no longer be linked. I've broken the link there. But since I'm saying my salsa is the original salsa, in this case, because of the way with lists work, we have to keep in mind that they are the same list. If we want a copy of the list that won't change when we change the original, we can do that by saying list. And this is another built-in function which is used to cast objects to a list. And in this case, since it already is a list, we're just creating a new identical list.
Stuart?
Yeah?
There's just a message in the chat saying that you need to just slow down for a bit.
Oh, that's okay. I seem to have lost my chat. So if you have any questions, you can put it in the chat and the other helpers will take a look. Otherwise, you can feel free to just interrupt me and shout out. So I'll slow down. So I'll go over this again. So we have our list of food. We have peppers, onions, cilantro, and tomatoes. And we create a new list called my salsa, which which is equal to salsa. And because salsa is a list which is mutable, they are effectively the same thing. So if I change the original salsa, if I change a value inside it, then it'll change in the new list. If I use this function list, then it won't change because now I've created a copy. Okay. So this is just something you have to keep an eye out for. It's a mistake everyone makes at some point when working with lists. And it is the scourge of Python to find out what's going wrong with it. So one useful thing you can do with lists is nested list. Another way of referring to it is two-dimensional lists. So if I create my list, I'll call it X, and this is effectively just a list of lists. So like I said earlier, we can put anything we want inside a list. So that can include other lists. So if I put in another list like so, and inside this list, I say pepper, zucchini, onion, and then I can create another list. And for clarity, I'm going to put it on a new line. Python is okay with this as long as I make sure to close the parentheses at some point. So now I want to create another list. And in here, we'll put cabbage, lettuce, garlic, and we'll create one more, apple, pear, and banana. So now we have a two-dimensional list. So I'm going to bring up an image to kind of visualize what's happening here. So when you want to index a list, we have this kind of analogy of a pepper pot with pepper bags and peppercorns. So the individual values are individual peppercorns. The lists are the pepper bags, and the list of lists is the pepper pot. So if we look to the left here, we can see when we call X, we have a pepper pot filled with pepper bags filled with peppercorns. So that's the entire list. If we then say a new list, but with only the 0th element of X, then that'll be a pepper pot with one pepper bag in it. So that is the entire list with a single list inside of it. If we then just say X0, that'll give us the 0th list in our list of lists, which is just a single pepper bag. And X00 will refer to a single peppercorn. You may notice this syntax is a bit different to working with NumPy. With NumPy, you would reference rows and columns using a comma. This won't work with built-in Python lists. It needs to be a single number in each index. NumPy is built to handle that for simplicity. Python isn't by default. So doing this will give us zucchini. So that takes the 0th list and the first value of that list. So, and I should be saying print. Jupyter doesn't explicitly need you to say print for some things, but it's good practice to always do it anyway. Some or most development environments will require you say print. And if I just print x0, that'll print the entire 0th list. And of course, x1 and x2. So if I wanted to reference a specific index, I specifically wanted the second element of the last list. Can someone tell me how I would do that?
Second element of the last list. Is that the question?
Yes.
So that would be.
Sorry, sorry if I mispronounced your name. Amphrocio, your mic is on. Could you? Thank you.
Okay, so that would be x square bracket 2. And then square bracket 1.
Okay, so remember to index one of these lists, we use the first bracket.
Mm-hmm.
Yeah, so if we do that, we do get pair.
Okay.
Another way of doing it is to use -1. This will guarantee that no matter how long the list is, we will get the final element.
Mm-hmm.
But 2 also works if we know the list is 3 elements long, or if we specifically want the element at index 2.
Okay.
So good answer.
All right, thank you.
So another little tidbit, we don't specifically have to use one type. So if we are working in Numpy, I'll quickly import Numpy to show. So if I create an array, numpy.array, this is another way of creating arrays where you can convert a Python list into an array. So Numpy arrays only work with one type at a time. So if I put in 0, 1, 2, and I need to print x, then you can see it prints 0, 1, 2. And I can also print x.dtype, and it's int 64, so it's an integer. If I make one of these values 0.0, now all of them become floats. Numpy arrays can only handle one data type. I can also use strings. So if I cover this in a string, now all of them are strings. So what Numpy will do is it'll try to simplify the list contents to the most general data type it can. And the most general data type, I believe, is a string. So if any of the values are a string, all of them become a string. If all of the values are numbers, but one of them's a float, then all of them are floats. If all of them are integers, then all of them will remain integers. And Numpy will do that on its own. But Python lists can contain any types we want, and it won't change them. So if we have a list of ages, and we have an age of 10, 12.5, and unknown. And if we then print ages, we can see it preserves the types. 10 is still an integer, it doesn't have a decimal point. 12.5 is still a float. Neither of these two have quotes, so neither of them are strings. And unknown is still a string. So aside from specifically assigning values to a specific index, as we saw earlier, so if we come back to our list of odds, So earlier we saw we can change index 0 to be something else. So we can make it 9. But another way of adding values is to say append. So odds and dot append. So this will tell the odds list that you want to add a new value to the end of it. And so I want to add 9, which is the next odd number, and then print odds. So now you see we have 5 elements in our list, 1, 3, 5, 7, and 9. And we can do that as many times as we want, with as many values as we want. And it'll always work. So we can also remove values in a similar way using pop. So if we say odds.pop 0 and then print odds, that will move the value at index 0. So it's removed 1. And if we, another function we can use is reverse. So if we say odds.reverse and we print odds, now the list has been inverted. So I'll put some strings in for clarity. So after appending, after popping, and after reversing.
Stuart?
Yeah.
For odds.pop, do you have to put the index instead of the value?
Yes, this takes an index. So if I put 2, it'll remove 5 instead. So you see 1, 3, 7, 9. So instead of looking for a value 2, it's taken the index 2. And if I put 1, which is a value in the list, it'll still just take the index 1. So it'll remove 3.
Okay.
There is a way, I believe, of removing by value. I'll have to look up quickly. It's been a while. So you can also use the remove. So odds.remove 1. So you see, after popping, we had 1, 5, 7, 9. And using the same value 1, which if taken as an index would have removed 5, it instead removed 1, the value. If I try to put in a value that doesn't exist, if I put in 2, we get an error. It says it tried to remove X, but X is not in the list. So we put in 1. I don't actually know if pop works with negatives. Oh yeah, it does. So you can use negative indices as well with pop. So lost my place. All right. So once again, if we create a new odds list, 1, 3, 5, and 7. And now I want a separate list of prime numbers, but prime numbers are very similar to odds, just with 2 as well. So if I say my primes is equal to odds, and now primes.append 2, that should give me all the primes up to 7. So if I print primes and I print odds, you can see it's actually added in both lists. And that's because of the mutability issue we saw earlier. So because I didn't make this a copy, when I called append, that doesn't create a new list. It edits the existing list. And so it's edited both of them. So if I want to say list odds, now I know that they're completely different lists, and primes will be the only one with 2. So when working with NumPy yesterday, you worked with subsetting lists. And this can be done with Python lists as well. So if we take a name of oh man, I have to type this out now. Drosophila melanogaster, which is the scientist's way of saying fruit fly. And now we say group, because scientists have a very particular way of naming things. So the first name here is the group, and the second name is the species. I want to get just the group. So I can say name 0 to 10. And then I can print group, and that'll give us Drosophila. And then I can also get species, which will go from index 11 to 23. And I should say species. And there we go. We've separated Drosophila and melanogaster. And we can do the same thing with lists. So if I have a list of chromosomes, so we have X, Y, 2, 3, and 4, and I've made all of these strings. A subset of the chromosomes is the autosomes, those 3 numbers. So I can say autosomes is equal to chromosomes 2 to 5, and that'll take indexes 2 to 5, and 5 isn't included. So it'll iterate until it reaches 5 and then stop. So if we print autosomes, then we get 2, 3, and 5. And of course, we can still say the last value is -1. That'll always work. So now we have some exercises. I'll put them in the Carpentries Etherpad. If we haven't already, can someone put a link to it in the chat? I can't seem to find my chat, it's disappeared. So I'll put them at the bottom here. So we have 3 exercises here. If you want to work through those for the next, say 5 or 10 minutes, I'll put up a timer. So we'll say 5 minutes because I'm running a little behind. So we'll start that, and once this timer runs out, we'll resume. If anyone has any questions, I'm right here. Okay. So that's the time for that. Again, if anyone has any questions, feel free to shout. I'm going to go through the answers now. So starting with slicing from the end. So I'll start by just copying their code into here. So we have these two lists, and our task is to access only the last 4 characters of a string or entries of a list. So we have the string, observation date, and this list of elements. So in order to access the last 4 elements, we do that by saying, so for the string, we would say, I want to go from element -4 onward. And there we have the last 4 characters of the string. And if we want the list, we do just the same, -4 onwards. And we have the last 4 sublists of the list. It doesn't have 3. So once again, we could do this by saying for the list, we could say from index 1, and that would work. You can see here's one case where that's not very practical because we have a ton of characters here, over a dozen, and I would have to count all the way up to here. So that's why it's useful to be able to say, I want to go from -4 onward. So for the second question, or the second exercise, non-continuous slices. So we can take this array and this subset takes a third argument, which can be used to skip values. So in this case, we only want to take every third value. So we take 2, 7, 17. And of course, this is always going to include index 0 and exclude index 12 in this case. And if we want to start in a different position, we simply change the starting position here. So this will take us to index 2, which is 5. So now the task is for this string, I believe, what slice of this variable will give us this. So the answer was to take beetles from index 0 to 35 and every second. And as you see there, we have the same string. So if I now go to exercise 3, overloading. So normally with mathematics, addition, 5 plus 10, plus will normally mean addition. With strings and lists, it means concatenation. So 5 plus 10 with strings gives us 510. and hello and world gives us hello world. We can also do this with strings, with lists, sorry. So if I print 1, 2, 3 plus 4, 5, 6, then we get 1, 2, 3, 4, 5, 6. So the question was, what does multiplication do? So if we look at this code, we can see it's what will the output be? And we can see the answer is answer 1, which is to repeat the list by concatenating itself onto it as many times as we specify in multiplication. If I say multiply by 3, we've concatenated to itself 3 times. Okay, so we'll now move on to the next lesson, which is repeating actions with loops. So lists are useful tools. We can subset them, we can index them, we can reverse them. But if I have a list of odds again, and that's not odds, an inconvenient thing to do is if I want to print all of the values separately. So I want to print odds 0, print odds 1, print odds 2, and print odds 3. And that alone, I can type fairly fast, but even that was fairly slow. But it does work. We printed all 4 values of the list. But this has a few issues. One issue is if I change this list, so now it's only got 3 elements, we run into an error. It's trying to print the value at index 3, but there is no value there. The list isn't that long, so it gives us an index error. And alternatively, if I were to make the list longer, we still only print those 4 values. We aren't printing 9. And one major issue is if I was trying to do this, if odds was a string, and I was trying to do this for Drosophila melanogaster, I'm not sure if I spelled it right, but you can see I don't even know how many characters are in there, and I would have to first count the characters and then put a print statement each time. I could use copy paste to make it go faster, but in the end, if I have a list of 1,000 values, I have a large data set, that's completely impractical to do. So that's where we come to the concept of a for loop. So I'm going to start by saying odds again is equal to 1, 3, 5, and 7. And so the syntax for a for loop, first of all, is to say for, and then we want to create a variable. We can call it whatever we like. In this case, I'll call it num, short for number. And this is going to be in odds. And what this will do is it'll say for every number, so this can be any value, doesn't have to be a number. This list could be strings, integers, floats, or other lists. But for every value within this list odds, I'm going to assign that value to this variable num. And we have to make sure to always finish the for loop with a colon. That tells Python we're finished defining the for loop and we want to move on to the next part. So you'll see in many IDEs, Jupyter included, they will automatically give you this indentation. And that is very important for for loops and a few other aspects of Python where we now want to define the contents of the for loop in this indented space. So everything after the for loop that is indented will be part of the for loop. So if I print num, that print statement, since it's indented by either 4 spaces or a tab, it will print it'll assign the values of odds to num and then print num for every value in odds. And you can see this is much more practical than manually printing. We can add more values and it automatically adds them. Or we can remove values and it doesn't throw an error. So and like I said earlier, this doesn't have to be called num. It can be called anything. We can call it banana and it'll work just fine. So a visual, so here we have a kind of visualization of what's happening. So we have our array odds and it has values 1 to 11. And we take this new variable num and we assign it to every value of the list and then every value we want to print it. So we take all the values of the list and one at a time we go through and perform print on them. And it's important to clarify how the indentation works once again. So if I create a new line and I say print end, you'll see it continues to print end at the end of the loop every time. And that's because it's still indented. If I wanted to only print once the loop is finished, I need to put it 1 indentation back. So normal indentation. And there we go. It only prints at the end. But if I now want to add something else, I want to say loop end. This will give us an error because it's done after. We have to make sure the indentation is consistent. And I mentioned earlier about tabs and spaces. Python will only let you use one or the other. So if you use spaces, which is usually 4 spaces, then you have to make sure you keep using spaces. A lot of IDEs will automatically, when you press tab, convert it to spaces. But if you're working on command line or just a normal text editor, you will have to do it manually. But if you use tabs, always use tab. If you use spaces, always use spaces. So printing the values of the list is handy, but that's something we've seen before. We can just print odds and it'll print the list. One useful way of using loops is to calculate the length of a list. So I have a variable length and we'll start it at 0. And I have a list of names. So we'll once again say we have Curie, Darwin, and Turing. So I want to know the length of this list. So I will say for value in names, and I want to say length is equal to what length currently is plus 1. So it'll start at 0, and when it goes to the first value, it'll say 0 plus 1, second value, 1 plus 1, and so on until it finishes. So then at the end, I want to say print length. So there are length names in the list. And we can see there are 3 names in the list. If I want to add another name, now there are 4 names in the list. So it's still robust. So one thing to keep in mind is this concept of scope. So if I create a variable called name, and we have Rosalind, and then I say for name in this list, Curie, Darwin, and Turing, and always put the colon, and then I print the name. So if I now say after the loop, name is name, what do you think name will be? Will it be Rosalind or will it be something else?
I think Rosalind.
Okay, so let's find out. So after the loop, the name is Turing. And so the reason for that is most programming languages would actually have the behavior you expected because they define scope slightly differently. But in Python, I create this name here, and this for loop creates name in the same scope. So it's actually overwriting our old name since they have the same variable name. And so when it gets to the end of the loop, it's assigned the value Turing to name, finishes the loop. And so since the last value that was assigned to name is Turing, it is still Turing. So it's always important to keep an eye out. Make sure you just, in general, don't use the same variable name twice because you can get very confused very easily doing that. I know I have plenty of times.
Sorry,
Yeah.
on the line 73, how come the output says there are 4 names in the list?
I just hadn't re-executed it, sorry.
Oh, okay.
I removed the value without running the cell again. That was my fault. That's a thing with Jupyter. You have to keep in mind if this is what you're using or any notebook. If you forget to run the cell, it can be confusing what the output is. So that's something you should always remember to do. I tend to forget sometimes as well. Okay, so the length function we saw earlier is useful. So useful, in fact, Python actually has that built in. So if we print, and the function is called len, which is short for length. So if I put in this function a list, and I have 0, 1, 2, 3, you can see it prints 4. We have a list of 4 values, and len tells us that. So now we're actually a bit ahead, and we have a few more exercises. So I'll put these in the Carpentries Etherpad again. And so if you want to get started on those, So we have a few exercises here, starting from 1 to n, and we have a total of 5. So I'll give you 10 minutes to go through those. I'll start the timer. And feel free to ask any questions. I'll be here the entire time. Okay, so that's time. So I'll now go through the answers. So starting with from 1 to n. So question talks about this range function. So range is a function that creates a list of values from one area to another. So if I say range 0 to 10, that should give me 10 values starting at 0, ending at 9. Because of course, in Python, ranges and subsets are exclusive on the maximum value. But if I print this, one thing to keep in mind is we have a range object rather than a list. If I want this to be an actual list, which I can print, then I have to tell Python to cast it to a list. A range object is just a special Python thing that helps speed some things up. So with this range object, the task was to write a loop that prints the first 3 natural numbers, 1 to 3. And so to do that, we say for number in range. We can iterate over a range object. And the values we want to go over, does anyone want to say?
We have to print out 1, 2, 3, right?
Yeah.
So it ranged till 2.
Say again, sorry?
So the value in there would be 2 or 3.
So if we put in 3, we'll see what happens. So that's printed 0, 1, 2. And our task is to print 1, 2, and 3.
Okay.
So it's the right number of numbers. To get it to print 1 to 3, we have to tell it to start at 1. Since Python will normally, most programming languages will start at 0 by default. And then we have to tell it to go to 4 because, again, Python is exclusive on the max. It doesn't include the maximum value. And so if we do 1 to 4, we get 1, 2, 3. So the next one is understanding the loops. So we have a word oxygen and the for loop print character. And the question is, how many times is the loop body executed? So what we can do is on Zoom, we have a show hands feature. So if anyone thinks the answer to this is 3 times, can you click on the show hands button? Okay, so that's no one. If anyone thinks it's 4 times. And if anyone thinks it's 5 times. And if anyone thinks it's 6 times. Yep, you're exactly right. It will print 6 times, once for every character in oxygen. So the next one is computing powers with loops. So exponentiation, which is x to the power of y, we have, in this case, 5 to the power of 3. So 5 times 5 times 5, that gives us 125. And we want to create a loop that does the same thing, 5 to the power of 3. So to do this, the first thing we want to do is we need a variable to actually have our result stored in. So we'll call this result. And for now, we'll leave it blank. This would throw an error, so we do have to put a value in at some point. But as long as we remember to do that later on, it should be fine. So we can say for number in range 0 to 3. And a shorthand for this would just be to say in range 3. Because range defaults to starting at 0. So I want to say result is now equal to result times 5. And if I then print result. So what do you think we would have to initialize result to be in order for this to work?
5.
All right, so if we initialize it to 5, let's see what happens. We get 625. Reason for that is we've started by 5 and then we're timesing it by 5 3 more times. So that was close. If we start with 1, then when we multiply it by 5, if we multiply it by 5 no times, then we'll end with 1. And that's just the result. That is actually the result of 5 to the power of 0. So that works. If we multiply it by 1, 5 to the power of 1 gives us 5. 5 to the power of 2 gives us 25, and 5 to the power of 3 gives us 125. So next we have summing a list. We want to write a loop that calculates the sum of the elements of this list. So we have a list numbers, and it has the values 124, 402, 36. And this should sum to 562. So I'm going to use comments, which I believe was shown yesterday. If it wasn't, I'll give a brief explanation. So a comment is basically everything after this hash symbol Python will ignore. So I can say should sum to 562. And this is just a short note I can look back on so I know I don't have to go to another screen or anything. I know here this information is relevant to this line. I can also put it on its own line. And comments are just really useful for explaining code to both yourself and other programmers when you look back at it a month later. So when you're writing code, the more code you're writing, the more important it is to add more and more comments. So we have our list of numbers that we want to sum. So for summing, we'll start with 0. So we have summed equals 0. And then for num in numbers, we want to iterate over the numbers in the array. We will then say summed is equal to summed plus num. And what that will do is num will be assigned to every value one after another, and we'll be adding that to summed. So if we then print summed, we get the expected answer of 562. So the last exercise was computing the value of a polynomial. And this one seems to be a bit of a tricky one. So we have this built-in function enumerate, like so. And if we give it a list, 1, 3, 5, and 7, then that creates an enumerate object, which is similar to how Python has a range object. It's just faster sum operations. We can convert it to a list though. And there we see we have a list of tuples. And for now, these are effectively just normal lists, except you can't write to them, you can't change them. And they are denoted, so a normal list is denoted using square brackets, a tuple is denoted using round brackets. There is also a set, which is defined using curly brackets, but for now, it's not too important. So when iterating using an enumerate, you can say for value, or you can say for tup, short for tuple, in enumerate 1, 3, 5, and 7. And if I print tup, then you can see it prints those tuples. And if you look at the values of the tuples, you'll see the first value is an index 0, 1, 2, 3. And the second value is the actual value at that index in the list. So a useful thing we can do is, I can't remember the name of it, but we can split the values of the tuple, of each tuple, into 2 separate variables, or however many variables would be in the tuple, which in this case is 2. So we take the index and separate by a comma, we take the value. So if I now print value at index is val. Now we see value at index 0 is 1, 1 is 3, 2 is 5, and so on. So now we want to we have this polynomial equation. So if I go with their code, they start by saying x is 5, coefficients is 2, 4, and 3, and y is coefs 0 times x to the power of 0 plus coefs 1 times x to the power of 1 plus coefs 2 times x to the power of 2. And we want to print y. So to kind of visualize this, I'm going to put a comment. This is equivalent to saying y equals 2 plus 4x plus 3x squared. And so if I execute that, we get 97, which is the expected output. And so the task is, using enumerate, we want to do this line in a loop. So to do that, I'm going to start by removing this, and we say y is equal to 0. Now we want to iterate for index and value in enumerate coefficients. So for every value in coefficients, we'll have 2 and 0, 4 and 1, 3 and 2. And in this case, that should match up to the powers that we need to do. We need 2 times x to the 0, 4 times x to the 1, and 3 times x to the 2. And so we can then say y is equal to y currently plus value times x to the power of the index. So if we execute that, we still get 97. So it's worked. So another brief explanation why we add the value. So we add the old value of y, which starts at 0 and is incremented every time. And we add the coefficient, which in the first case is 2, multiplied by x, which is 5, to the power of index. And for the first index, that is 0. So we just add 2. X to the power of 5 to the power of 0 is 1. And then we take 4 times 5 to the power of 1, 4 times 5, 20, 22, and so on. So that's the second lesson. We can now move on to analyzing data from multiple files. At some point today, we'll probably want to take a 10-15 minute break. So if you want, we can take that now, or we can take it after this lesson. This lesson is expected to take 45 minutes.
Hello? Hi.
Good to continue. Show of hands if you're good to continue.
Hi, Stu. There's just a comment in the chat asking to just go through that last piece again.
All right, yeah. I agree, this one's quite messy. So the goal with this one is okay, so we start with our value x, which we are going to say is 5. We can change that to any value we want. This is just algebra. We know what x is and we want to find y. And this is the algebraic notation for what we want this for loop to do. So I'll put this here at the start. So we want to say y is equal to 2 plus 4x plus 3x squared. So we start by saying I have this array of coefficients. The coefficients are just the numbers, the constant numbers here that we multiply x by. And a useful trick with this kind of algebra in maths is we can make this more generic by saying x to the power of 1 and x to the power of 0. This equation hasn't been changed at all. It's mathematically identical because x to the power of 0 becomes 1, and 1 times 2 is just 2. But notating it like this is helpful for here, because if you notice, we have the indexes 0, 1, and 2. So if we order our coefficients in the same order that we increment the powers, then we can use this enumerate function on here. And so if I print list enumerate coefs, you can see this maps out perfectly. So we have, if we treat the left hand, which is the index, as the power, and the right hand as the coefficient, then at the first index, we have x to the power of 0 times 2, 2x to the power of 0. On the first index here, we have x to the power of 1 times 4, x to the power of 1 times 4. And on the second index, we have x to the power of 2 times 3, x to the power of 2 times 3. And so we can iterate through this enumerate, which we do here, taking the index and the value. I'll call this coef for clarity. So this value is a single coefficient in the array, one at a time. And then we say, I want to increment y by the correct by one of these at a time. And so this is the data we have for 2x to the power of 0. And so we say coefficient, which is 2, multiplied by x, which is our variable, which we can change, to the power of the index, which starts at 0 and increments for each one. And as I said earlier, we've ordered this in incrementing values of powers, or incrementing order of powers, such that coefficient, the first coefficient will be x to the power of 0 and so on. So this this part here is the important part where we actually calculate each of these individual parts, and then adding that to the parts we've calculated before and assigning that to the variable. So does that make sense? If it doesn't, it shouldn't matter too much. It's a very messy and complicated exercise. If that doesn't make sense, can you show a hand? Okay, so we've got no hands. So I think I'll move on to the next lesson then, which is analyzing data from multiple files. So one thing we need to do before we can iterate through our files is we need to be able to actually get the files to iterate through. So as I said earlier, we can just say file names is equal to, and then we can go in and copy paste all of these names. So if I information, so if I say information 01.csv, I could then copy paste and just change the number every time until I've got all of them. But we established earlier, this is a very poor way of doing it. So what we can do is we have this library in Python called Glob. And the reason it's called Glob, I'm still uncertain. It's global expressions, I believe, and I still don't know what that means. It's an acronym of an acronym of a shortening of an acronym kind of thing. It's an old name for an old concept. So we want to import this library called Glob, and the purpose of Glob is to search through file systems. So we do this with Glob's function called Glob. And to access it, we say glob.glob. And so this will take the Glob function in the Glob library. And then we say, I want all files. So in here, we have to put a string. And in this string, we have to put a regular expression, which is a kind of description of a string, and it'll look for anything that matches that description. So I have this file. So if I put in just information 01 CSV, like I did earlier, it'll only find this file. It's going to look for an exact match to this string. So what I can do, the only part of this that actually changes is this number here. So I can replace that with an asterisk. And what that will do is it'll tell Glob, I want to look for anything that matches, that starts with information and a hyphen, ends with CSV, and has one or more or 0 or more characters between. So an example match would be just that. This would match. That would match. And that would match. As long as it starts with information, ends with .csv, it'll match. And so if I print that, it won't work because I have mine in a directory. Some of you might actually have the same. So my notebook is here, Python 2, and my data is in this data directory. So I need to make sure to specify data slash. And there we go. So now we have all of these files, all these file names. So what I want to do is I want to plot the data in all of these file names like we did earlier in yesterday. So I'm going to start by importing Glob, importing Numpy, and importing Matplotlib.pyplot. So the first thing I want to do is get the file names. So I'll say file names is equal to, and in Python, we have this built-in function called sorted, which will take a list and sort it by whatever values are inside of it. So we're working with strings, it'll sort it alphanumerically. If we had numbers, it would sort them numerically. And I'm pretty sure that it has a way of sorting different data types as well. So if we then say glob.glob and inflammation, so data slash inflammation hyphen asterisk.csv. And so that should give us all of our file names. And to be sure, we can print file names, or we can just print the length of file names. That way, if it's 0, we know we've put in something wrong. And if it's 12, we know we've got the right number of files. So I can leave that in safely. It won't be a mess of information here. So just to clarify, since we're going to be printing other things, I'm going to put in some text here. There are this many files. So since we are going to be doing this to test, we don't want to use the full data set right away. So one thing we can do to simplify this, which is especially helpful for really big data sets that can take on the order of minutes or hours or even days to process, we can just take a subset. So we could say file names is equal to the subset of file names from 0 to 3. So we just want the first 3 files. And now I want to say for file name in file names. And it's important to make sure you're consistent. In fact, I normally like to make sure the variable has a very different name to the list it's iterating through, because file name is very easy to confuse for file names. At a glance, they look like the same variable. So I'll just be calling this file. And I'll start by printing file. So every time we iterate through the loop to draw a new graph, we'll be printing its name first, so we know which one we're looking at. So I'll start by getting the data. We saw yesterday we can do this with numpy.load text. And the file name should be file, and the delimiter should be a comma. And then we want to create a Matplotlib figure, which is done with Matplotlib pyplot figure. And we can say fig size is 10 by 3. I believe that's in inches. So now we can create our 3 axes like we did yesterday. So we want to create axis 1, is figure, add, subplot. We want 1 row, 3 columns, and we want this one to be index 1. And that shouldn't be a space. And then we want axis 2 is figure, add, subplot, 1, 3, and the second index. And then axis 3, add, subplot, 1, 3, 3. So then we can set the, we can start plotting axis 1. So we can say axis 1 dot plot numpy dot mean of the data for axis 0. So we want the first axis to plot the average. And we want to say set y label to average. That way we can differentiate between the different graphs when we plot them. And we do the same for the other 2 graphs. So we have axis 2, set y label, and we're going to make this one the max. And we plot numpy dot max data on axis 0. And then we do axis 3, set y label to the min, axis 3 dot plot numpy max data axis equals 0. And now we can say fig dot tight layout. And that's a fairly generic function in Matplotlib, which tries its best to organize the graph neatly. It'll try and prevent overlapping text and messy graphs. It's not perfect, but for simple graphs like this, it works just fine. And unless you're doing something insanely complicated, it should normally just work. So now, of course, we want to say matplotlib pyplot show. So I'll leave that there for a couple minutes for people to write out. If you want to raise a hand when you've finished, and then we can continue whenever we're on stand. I'll zoom out a bit so we can see the entire thing. So if you want to click the raise hand icon on Zoom when you're finished, so I know. Again, if you're having any troubles, feel free to shout out, or you can ask a question in the chat and one of the helpers will come to you.
Let's do it.
Yeah.
Yeah, I'm having a bit of an issue on my side. I can't really figure out. Mind if I share my screen?
Yeah, sure.
Guys, I'm getting this error. Can you see my screen?
I can, hold on. There we go. I can see your screen.
All right, so I'm getting this error here. So it says something by line 18.
So you've typed access. So inside your NumPy functions, you've said access with an E.
Oh, I see.
Yeah. So the two different spellings are just singular and plural. So you have one axis and multiple axes. So
Yeah.
that should work. There you go.
All right, perfect. Thank you.
Okay, I'll leave this up for one more minute and then I'll continue on.
Sorry, can I also share my screen? I've got an error that
Yeah, what's up?
I received an error, so I was wondering if I can show my screen.
Yeah, sure. Should be able to share screen. Okay, so that should be fig size equals. So Python was thinking you were trying to call a function called fig size, which doesn't exist. There you go.
Thank you.
Okay, so I'll put the code here in the Etherpad just in case anyone's still behind. And it would help to actually copy it. All right, so that's there for anyone who still needs it. And if I now execute this, I'll be amazed if it works first try. And it actually does. Well, so we see here we've printed the contents of 3 files. And we have a total of 9 graphs, 3 for each. So the plots we have look very similar to the original, the first data set we looked at. The average plots are noisy and their maxima are linear, and their minima are also linear. The third one, yeah?
Sorry, it was just pointed out in the chat, the last plot that you have, you're actually repeating the maximum twice.
Ah, I thought something was odd.
Yeah.
Thank you. So it didn't work first try. All right, so yeah, that's more what I was expecting. So we have the maxima plots are linear, the minima plots have this step artifact, and the average plots are noisy, but also somewhat linear. The third data set here has results more in line with what we would expect. The minima is closer to 0, or it is 0, which makes sense because it's the minimum. And the average and maxima are more noisy. So if we can visualize this better if we plot a heat map. I unfortunately can't remember how to do that. Should just be a simple change. It's imshow. I believe if we replace this with imshow, it should work. I am wrong. Okay, so I think what I actually need to do is if I comment these out, so these will no longer execute. I only need 1 axis. And for now, I'll say it's 1 row. And then I'll say imshow data. There we go. So now we can see the 3 data sets in a heat map format. I'll show you the code again. So it's just, we only need 1 axis. We use the imshow on the entire data set. And that creates a heat map. So we can see if we look at data information 3, the bottommost line has no data, which isn't what we would want. And that's what created the flat line at the minimum. And if we actually look in more detail, we can see that it seems to be a lot of 0 values, a lot of missing data. So that can be a sign of data corruption or just a need for some cleaning. So we now have a few more exercises again.
Yeah.
And we've been going on for quite a while. So what I'll do is we'll do these 2 exercises. I'll go through the answers and then we can take a 10-minute break. Is everyone okay with that?
That's good. There's one question in the chat asking why is only 1 data set being used for the heat map?
So with the plots, what I'll do is I'll show all 4 of them at the same time. That should hopefully help. So I'll create a new axis, axis 0. I'll move that there. So I'll say axis 0 is fig, add subplot 1, 4, 1. This one can become 2. I'll remove all of my comments. So now I want to make sure all of these are 4, and then all of these increment correctly. This should be axis 0 that I'm making a heat map on. And that should work. No, it shouldn't. Imp show. There we go. So these, if we look at this first data set, these 3 line plots here are for a specific subset of the data. So if we look vertically in this data set, for every column, this first graph is looking for the average of all those values in each column. The maximum is looking for the largest value in each column, and the minimum is looking for the lowest value in each column. So if we again look at this data set, we can see the minimum in all columns will be 0 because of this bottommost row, which has all zeros. And that's why we see this artifact here. So the line graphs are working with single subsets of the data, a selective row of data, but the heat map is looking at the entire data set, all rows and all columns, and showing it in image format. Does that make sense? I'll take your silence as a yes. So we have 2 exercises to go through. And then I'll go through the answers, and then we can take a 10-minute break. So starting from plotting the differences and generating composite statistics. So I'll give you 5 minutes for these 2 exercises. I'll be here if you have any questions. Okay, so that's time. If you're not finished, we can continue over the break. I'll go through the answers now. Okay, so the first exercise was plotting differences. So we want to plot the difference between the average informations in the first and second data sets. All right, so to do this, we of course start by importing our libraries, Glob, Numpy, and Matplotlib. And now we want to get our file names. We do this the same way we did earlier. And now we want to take specific files from this. So we can say data 0 is equal to numpy load txt, where the file name is file names 0. So the file at the 0th index. And then the delimiter is, of course, a comma. And then we can say data 1 is numpy load text. File name is file names 1. So that'll get the first two file names from our list. So we can then say our figure is a Matplotlib figure. And the fig size is equal to 10 by 3. And since we're using only one, we're only plotting one thing, we can just, we don't need to create any axes. So we're looking for the difference in age, or no, average, sorry. And Matplotlib, plot, and we want to plot a line graph of the mean for data 0 on axis 0 minus the mean of data 1 also on axis 0. And so then we can say fig tight layout and Matplotlib pyplot show. And so this should throw an error. I forgot to put data in again. So the error we got here was list index out of range. So the fact that file name 0 threw this error, as we can see here, the fact that the 0th element threw an error, we can tell for some reason the list had no values in it. And the reason for that was because Glob wasn't actually getting any values because I put in the wrong name. There we go. So this shows the difference in average. In theory, if we are looking for the difference and we don't care about which one's larger or smaller, we can plot the absolute. I believe Numpy has a function for it. Yes, it does. So if we only care about the size of the difference and not not which one's larger, then we can just say numpy abs, and that'll give us the absolute value, so we won't get any negative values. But for the exercise, this is what we're looking for. And then generating composite statistics, the second exercise. So we start by saying, so in their code, they have file names is glob.glob data information. And so we've got the file names, and we have composite data is numpy zeros. And what this function will do is it'll create a new numpy array filled with only zeros, and it'll be in these dimensions. So it'll be 60 rows, 40 columns, all of them being 0. And then we can iterate through our files. So we can say for file name or file in file names, and they have a comment here. And at the end, composite data is composite data divided by the length of file names. And so the task is to plot, to use PyPlot to generate average, maximum, and minimum for all patients. So to do that, we, in this for loop here, we start by pulling out the data. So we say data is numpy load txt. The file name is equal to file, and the delimiter is a comma. And with the data, we can then simply add to our composite data and this is a fancy way of calculating the average over a two-dimensional array. So we just create a 2D array, so 60 rows, 40 columns of zeros, and then we add all of the data values for each point to each point, and we divide by the number of times we've done this. So once we've calculated the average, just going to put some new lines to make it look a bit cleaner. Now we want to plot it. So we can say our figure is Matplotlib pyplot figure. Fig size is, of course, 10 by 3. And we want to plot multiple things, so we create 3 axes. And we add the subplot for 1 row, 3 columns, and this is the first one. Axis 2 is fig add subplot 1, 3, 2. Axis 3, fig add subplot 1, 3, and 3. So now we want to plot on the axes, so we can say axis 1, we want to set the Y label, and this will be our average plot. And then we want to plot the mean of our composite data with an axis of 0. And we do the same, axis 2, set Y label to max. and we plot numpy.max of composite data. And then axis 3, we want to do the min. And so we plot numpy.min composites data axis 0. And finally, we say fig height layout and Matplotlib, if I can type, pyplot show. So if I now run this, we have 3 plots, and these are the same 3 plots we've done before, but each value is averaged across all the data sets. So I think we can take a break now. I'll put on a timer for 10 minutes. I'll be going for a couple minutes, but I'll say when I'm back. Feel free to shout out, ask questions in the chat if you need help, and see you in 10 minutes. I'm back in case anyone wants to ask me any questions. I see there's one hand up. Is that from earlier, or is it a question? Okay. I'm here if you need me. Okay, so that's time. We'll give 1 or 2 minutes for anyone still coming back. If you can put a hand to show that you're back, that would be appreciated. Okay, I'll get started then. So looking at the data we plotted earlier, so I've just gone back to here and removed the subset operation. So now we're looking at all 12 files. So if we look through them, we can see there's a lot of suspicious data, and some files are in fact actually identical. So if we look at information 3, information 8, and information 11, you can see comparing 8 and 11, there's no differences in the data set. They have the same artifacts and the same data. And we can use this to basically conclude that this data is in fact synthetic or very poorly managed at best. We're going to continue using it for future lessons, though, because it's a useful data set to work with. And our next lesson is making choices. So in this lesson, we're going to be looking at writing conditional statements using if, elif, and else. And we're also going to be using some Boolean operations to control those conditional statements. So to begin with, what is a conditional statement? So if we have a number, in this case 37, and I want to do one thing if it's greater than 100 and another thing if it's not, then I can say if, and if number is greater than 100. So we use this chevron here to indicate greater than or less than. Pointing to the right is greater than, and pointing to the left is less than. And just like with for loops, we have to end an if statement with a colon. So if it's greater than 100, I want to print greater. And if it's not, then we can say else, followed by a colon. And we can say not greater. And then at the end, we can say print done. And just like for loops, we have to be aware of indentation. The if and the else have to be on the same level of indentation. And if we want to leave the statement, we move down. So if I run this, we see 37 is not greater than 100, and then it prints down. So a diagram here, just a flow chart of what we've just done. If number is greater than 100, if that's true, then we print greater. If it's false, we print not greater. And then afterwards, we print done. So they don't necessarily have to include an else. We can, for instance, if our number is 53, we can say 4, and if the number is greater than 100, we print the number is greater than 100, and then afterwards we can just print after. And so you see, running that, it prints before and it prints after, but it doesn't go into the if statement. So the else part is optional. And another thing we can do, if we want to have multiple conditions, so if we were to use the flow chart, it would have 3 diverging outputs. There are 2 ways of doing it. Well, the intuitive way is to say, starting with numbers -3. So if number is greater than 0, then we print num is positive, and we say else if num is less than 0, we print num is negative, else we print num is 0. And this will work. We can see -3 is negative, so it makes its way just fine. But a much easier way of doing this is, instead of putting the second if else within the else statement of the previous, we can just say elif, and that is shorthand for else if. So if number is not greater than 0, and if number, then we move on to this line. If number is less than 0, then we execute this. If it's not less than 0, then we go to the else. We can see this also works just fine. So now we want to look at comparisons. So we've looked at greater than and less than, but there are more operations. So we can say, if I list the operations, we have greater than, less than, equal to, not equal to, then greater than or equal to, less than or equal to. So with equal to, we have to make sure not to confuse this with variable assignment. So when you assign a variable, you'll say the name followed by 1 equals followed by the value. But if you use 2 equals, that's comparing the left hand with the right hand. If I put a second equals here, Python will be confused because it'll think I'm trying to compare a variable named num with -3. So if I want to assign, I use 1. If I want to compare, I use 2. And there are also 2 more statements we can use, which are or and. So if we have a statement that is true or false, we can put that on the left of or, so we can say true or false. And if either one of those are true, this entire statement will return true. So as an example, if I create a new cell, if I say if 1 is greater than 0 and -1 is greater than or equal to 0, then I'll print both parts are true. at least one part is false. And as we can see here, at least one part is in fact false. And that'll be -1 isn't in fact greater than or equal to 0. And since one of them are false, they failed the AND check and returned false. If I say or instead, and then replace this here, so at least one part is true, and both parts are false. Then we can see, in this case, at least one part is true. One is, in fact, greater than 0, so it passes the OR check. Two keywords you may have seen me use earlier are true and false. These are the representations for these conditionals in Python. So I can say if true, print is true, and it'll print is true. If I say if false, it'll print nothing because it's false and doesn't go into the execution. So if we want to check our data, so if we import NumPy again, and we want our data again. So we want to say file. So we want to import NumPy, import glob. And our file names are glob.glob. And to simplify, I'm just going to use the file names variable we had before because Jupyter will save that. So just to be sure, I can print file names, and that is what I expect. So for clarity, you might want to recreate it again. And in some cases, that's the best thing to do in a Jupyter or in any notebook, because if you execute the cells in different orders, it can create unexpected behavior. But in this case, it should be safe. I've printed it and confirmed here that we have the data we want. So looking at our file names, we want data 0 is NumPy, or our data is NumPy.read CSV for file names 0. So we want the first file name. The limiter is a comma. I appear to have forgotten the syntax. It's load.txt. So it should be load.txt, not read CSV. So that's our data. And now I want to say max information 0 is numpy.max of our data on axis 0. And I'm going to take value 0. And then max information 20 is NumPy max of our data on axis 0 for value 20. So now I want to say if max information 0 is equal to 0 and max information 20 is equal to 20, then this will be considered suspicious in this case. So I want to say suspicious data. And if I execute, we get an error because I used a space instead of an underscore. There we go. So you've got to be careful with spaces and underscores, a space can't be used in a variable name, but an underscore can. If you try to use a space in a variable name, it'll confuse Python. So we see we've confirmed that this is some suspicious data using the conditional. And we can also confirm with a different data set. So using the third data set, so index 2, the third data set, if we take this data and we remember that the minimum was all zeros. So if we say if the sum of the minimum of the data on axis 0 is equal to 0, then we can print the minima add up to 0. And in this case, it does. And what we can do is we can actually put both of these in. So we can say LF here, and here we can say suspicious looking maxima. So if the maxima looks suspicious, we'll print that they are suspicious. Otherwise, if the minima looks suspicious, we'll print that they add to 0. And if neither of those are true, then we'll say data looks okay. So you can see here, this one has suspicious maxima. If I look at a different file, so we look at the second file, that one has suspicious maxima, index 5, and so on. So now, so if I was kind of expecting that to go to the second one, but it should be fine. Ah, that's why. So I've forgotten to copy this, the part that actually updates these two, and it's been holding the data from the last cell's execution. So if I run this now, there we go. So the maxima look fine in this case, but the minima are suspicious. So we now have a few exercises. So I'll put these in the Etherpad and we can do those. So starting from how many paths? Okay, so we have quite a few exercises. Don't worry if you don't get through them all. We'll go through the first few afterwards. I'll go through the answers, and we'll be leaving these in the Etherpad if you want to look at the remaining exercises on your own. So I'll give you 10 minutes for these, starting at how many paths. Okay, so that's time. So I'll go through the first three. In the interest of time, I won't go through all of them, but I'll put the answers in the Etherpad at the end of the workshop. So starting with how many paths. So we are given this code and we are asked, what do we expect it to print? So can I have a show of hands? Who thinks this will print A? Okay, and who thinks this will print B? Who thinks this will print C? Yeah. Okay, so we've got quite a few for that. And who thinks it'll print B and C? Okay, so if we execute that, we see you're perfectly right, it prints C. So now we have this question of what is truth. So in Python, anything can be cast to a Boolean. So everything has a true or false value to it. So if we run this, we'll see whether each of these values is considered true or not. And we can see an empty string is considered false. This didn't print. But a string with characters in it is true. And it's the same with an empty list, that's false. And a populated list is true. And then 0 is false and 1 is true. And you'll find all non-zero, or for most data types, there will only be one case which is false, which will be the empty case or the 0 case or the null case. And all of the cases will be considered true. So it doesn't necessarily apply to all data types, especially if someone creates their own. But as a rule of thumb, that tends to work. So now we have this concept of negation, where if we want something to not be true, then we do it. And we use this not keyword. So this just goes before the conditional we want. And it can even be self-referential. So we can say not true. And if we execute this, we can see not empty list, empty string prints, because an empty string is false and not false is true. So it negates the value that the empty string gets cast to. And if we try that on word, well, word would normally be true. So not true is false. So it doesn't print word is not true. And not true, the simple way of looking at it is to say we have two nots, so they cancel each other out. And the remainder is just true, so it prints. Okay, so if we move on to the next lesson. So in this lesson, we've looked at using if statements, we've looked at testing for equality, and we've looked at truth. So in this next lesson, creating functions, we are going to look at defining a function that can take parameters. So like print, we can create our own version, which takes our own parameters and does our own functionality. And then we're going to look at returning values from functions. We are going to look at testing and debugging functions, and then setting default values for the parameters. So a lot of our code that we've done earlier, if I scroll up to the chaos we had over here. In this for loop, we have a massive chunk of code, and it's not necessarily clear what it does, unless you were to put a bunch of comments in. But another thing you can do to organize this is use functions. So to define a function, we'll start by saying def. So this creates a new function, and we now need to give the function a name. So I want to create a function that will convert from Fahrenheit to Celsius. So we'll start by calling it far to Celsius. And because it's a function, we need these brackets here. And we finish it with a colon, just like an if statement in a for loop. And of course, in order to convert Fahrenheit to Celsius, we actually need a value that's Fahrenheit. So we take a parameter by saying temp. And in this case, this can be anything. It can be var, num, banana. But because I'm going to be using it as a temperature, I'm going to call it temp. So that is our parameter. That's what we'll input into the function, and that's what we'll work on. So on the next line, we want to return something from this function. So we want to take our value temp, convert it to Celsius, and send that back to whoever's calling it. So to do that, we say return, and then whatever we put after the return is what gets sent out to the function. And to convert from Fahrenheit to Celsius, we can say temp minus 32 multiplied by 5 divided by 9. And if I run this cell, nothing will happen because all it's done is created the function. We haven't actually called it yet. So if I now in this next cell say print freezing point of water, and then I want to call my function Fahrenheit to Celsius, and in Fahrenheit the freezing point is 32 degrees, and then I can say C, and then the boiling point of water is Fahrenheit to Celsius, and in Fahrenheit that is 212 degrees. And now we can execute this, and we'll see the freezing point of water is 0 degrees Celsius, and the boiling point of water is 100 degrees Celsius, which is exactly what we expect. So we created this function which takes a Fahrenheit temperature as an input and outputs the Celsius equivalent. So now, if we want to create a new function to convert from Celsius to Kelvin, and we want to take a parameter, in this case we'll call it temp C, so the temperature in Celsius, and to convert we just return temp C plus 273.15. And so we execute the cell, so now it's created the function, and now I want to print the freezing point of water in Kelvin, and I need to put that in quotes. So the freezing point of water in Kelvin, and we can call Celsius to Kelvin, and we know that the freezing point in Celsius is 0 degrees Celsius. So we can say execute that, and we get 273.15, which is what we expect. One thing we could also do just like with all the other functions we've done, is we can nest our functions. So I can say Fahrenheit to Celsius. And if I put in the freezing point we had earlier, which is 32, then we still get 273 out. So we can put as a parameter of a function the output of another function. And so now if I want to create another function, this time I want to convert from Fahrenheit to Kelvin. And I want to take a temp F Fahrenheit as input. And then I want, instead of calculating it in numbers, I already have these two functions that I've created. So I can say the temperature in Celsius is Fahrenheit to Celsius for the temperature in Fahrenheit. So I'll convert the Fahrenheit parameter we've been given into Celsius. Then we can convert the Celsius value into Kelvin by calling Celsius to Kelvin on the Celsius value. And then we want to return temp K. So that'll create the function. And so if I now print the boiling point of water in Kelvin, and I want to call Fahrenheit to Kelvin, and the boiling point of water in Fahrenheit is 212. And if I execute that, we get 375.15, which is what we expect. So one thing we have to keep in mind is this concept of scope. We briefly touched upon it earlier with the example of the for loop, where a for loop will preserve the value of this variable after the loop. With functions, it works a bit differently. So if I say temp Kelvin is equal to Fahrenheit to Kelvin for 212, so what we've done just before, and then I want to print temp K. This variable is defined in the function. And since we're calling it, it'll in theory be defined after we call it. But if we run, you can see it's not defined. So the way scope works with functions is a function will create a new variable, but once you leave the function, that variable is lost. It's discarded and you cannot access it outside of the function. So, but there is also, yeah?
Yeah, sorry, there's just a typo there. That's why it's giving that error.
Ah. Thank you. There we go. So we can see this time, if I actually read the error, it's temp K is not defined. So we've called this function. It has created temp K, because if we print the value that we've just created, then it does print that correctly. So it must have created temp K at some point, but after leaving the function, temp K has been discarded, so we can no longer call it. We can define temp K on our own. So if I say up here, temp K is equal to 5, and I run this now, you can see Fahrenheit to Kelvin calls, it creates its own temp K in its local scope. And then when we leave it, the local temp K is lost. And this global temp K remains. It has the same value as it did at the beginning. So the global temp k defined outside the function is not affected at all by the local temp k defined inside the function. And that's something I can very easily trip even the most experienced programmers up. So if we wanted to use a value that was in this function, we would have to return it. So in this case, we're returning temp k, so we can take that as the return value. So if I create a new function and I want this function to print some temperatures, so I'm starting by printing a temperature in Fahrenheit with a variable I have not defined locally. So since I haven't defined it locally, it'll look in the global scope for a variable called temp Fahrenheit. And then if I say temperature in Kelvin, and so if I execute this, even though I haven't defined this variable here, the function still gets created fine because it's not actually executing it. It's just creating it. But if I say print temperatures now, I will get an error here that says temperature Fahrenheit is not defined. So I have to first say temperature Fahrenheit is, in this case, 212.0. And we'll say temperature Kelvin is Fahrenheit to Kelvin of temperature Fahrenheit. So if I execute this now, you can see it recognizes the global variables, temperature Fahrenheit and temperature Kelvin, and prints those. If I were to overwrite those in local scope, so temperature Fahrenheit is 5, redefine the function and rerun this. Now temperature in Fahrenheit is 5. It's overridden the global variable of temperature Fahrenheit. So I'll re-execute these. All right. So now that we've learned how to use functions, we can clean up our old code. So if I go all the way back up to where we plotted all these files, all these graphs, and I want to copy the contents of the for loop. So I want to copy everything after for file in file names. I then go down here, and in a new cell, I want to create a new function. We'll call it visualize. And I want to take a file name as a parameter. I'll call it file because that's the variable I used earlier. And then if I paste, now whenever I call this function visualize, it will run all of this code that we saw earlier. It'll create 4 axes and plot 4 graphs. So if I run that, we have an error. I accidentally included this. So I don't want to print file here. There we go. Okay, so I had a statement after the colon, which is almost never valid syntax. And so it confused Python, or it's only valid syntax under specific circumstances, and that's what confused Python. So we can now create another function, and we're going to call it detect problems. And this will do, this will be for our code we defined earlier again with conditionals, where here we looked at the data and tried to find if it was suspicious or not. So I'll take this and I will create this function detect problems, and I want a variable, a parameter called file. And if I now paste this here, we now want to indent all of this. A useful thing some of your IDEs might have is if you select all of the text you want to indent and then press tab, it'll indent it. Not all of them will have that though. So if it doesn't, then you can just tab it manually and it works just fine. Now we need to change this code a bit so it'll work because we haven't defined these two variables. So we can say our data is numpy load text. The file name is file. The delimiter is a comma. And we can use empty lines to make it more clear. And then I want to say in here, if numpy.max of the data on axis 0 at the position 0 is equal to 0, and if numpy max of the data on the axis 0 at position 20 is equal to 20. I'm going to make sure to use 2 equals. If that's true, so the maximum value at position 0 is equal to 0 and the maximum value at position 20 is equal to 20, then I've found suspicious maxima. And then I want to say this code is fine. So the sum of all of the minimums, if that is 0, then the minima add to 0, that's suspicious. Otherwise, the data is okay. So I can run that. It creates the function. And now we can say, I want to grab my file names again. So this is sorted glob.glob for data inflammation.csv. And then I want to iterate through each file and say for file in file names, and we'll start by only looking at the first 3. And I want to, for each file, print the file name. And then I want to visualize the file name. So that should create the graphs, that should plot the data. And then I want to detect problems in the file name. So if I now run this, I will get an error because I'm using the wrong variable. So I've used file name instead of file here. And I've never instantiated that variable, so it doesn't know what I'm talking about. So if I do that, there we go. So it prints the file name, it plots the data, and then tells us if anything is suspicious. So we have some suspicious maxima. In dataset 2, we also have suspicious maxima. And in dataset 3, we have suspicious minima. So we've created our functions, and now we want to test and document them. So if I create another new function, I'll call it offset mean. And I want to take in 2 parameters. One is some data, and the other is a target value, so target mean value. And I want to return data minus numpy mean of the data plus the target mean value. So this will shift the mean data by a set value defined here. So if I run that, it'll create the function. And then if I say z is numpy of zeros, and I want a 2 by 2 array of zeros, and I want to print the offset mean of z offset by 3. That will offset all of the values by 3. So if we now try to do this on our real data, so we can say data is numpy load txt. And remember, since we have defined data in the local scope, this data will override this one. So when we refer to data here, we're referring to the local data. And this data is unaffected by the function. So I want to load text from the file name inflammation 01 CSV. And I need to make sure to put in data slash. And then I want a delimiter of a comma. And now I want to print the offset mean of the data offset by 0. And just looking at that, it's fairly hard to tell what we're looking at, if it's actually worked or not. So we want to, instead of printing the entire thing, we can say print original min, mean, and max are, and then the numpy.min of the data, numpy.mean of the data, and the numpy.max of the data. And then we can create a variable offset data, which is offset mean for the data. We'll offset it by 0. And then here, we can say the min, mean, and max of the offset data are. And then we can say numpy.min offset data, numpy.max, no, numpy.mean, sorry, of the offset data, and numpy.max of the offset data. So if I run this now, we can see the original min, mean, and max are 0, 6, and 20. And after offsetting, we get -6, 2, and 13, which is which seems almost right. But the original mean was 6, so the lower bound from 0 is now about -6. That means the offset beta isn't quite 0. We'll explore why in the challenges, but it's pretty close. We can go further and see if the standard deviation has changed. So if I say at the end here, we can say STD, the standard deviation before and after is numpy std for data and for offset mean. no, offset data, sorry. And we can see the standard deviation hasn't changed at all. So, but in theory, there could be one decimal point that is different. So to make sure, we can say, we can subtract one from the other and say the difference, and the difference is 0, so we know they're identical. So we spoke earlier about comments, and a very useful thing to do is put comments on your function to explain what they do. So in this case, we have offset mean, which returns a new array containing the original data with its mean offset to match the desired value. And so now whenever I look at this function, I can see in the comment here, this is what it does. But this doesn't really follow convention, because in Python, we have this thing called docstrings, and you denote those using 3 quotation marks with text inside. So it's a very big string. So if I take this and put it in the docstring, and I can put the docstring over multiple lines just fine. Everything between these 3 and these 3 will always be considered a string. So if I remove this, it'll now think that this text is part of the docstring. So I'll put it back. So the reason we use docstrings is because for one, it's conventional. You look at this and you can know this is going to describe the function. A comment will be more so a quick little piece of information. And another reason is because these can be converted into official documentation. There are some programs which will which you can have run through your code and read through the doc strings for each of your functions and create formal documentation for it. So another use of this, if I run this to create this function, if I, Python has a built-in function called help. And if I call help on offset mean, it'll now show me the contents of the docstring. So anyone who calls help, trying to find out what this function does, they'll see the description we put in the docstring telling us what it's for. I find when I write docstrings, it's best to put the string itself on separate lines, because this I find looks clearer. But semantically, it's identical. It just looks clearer. So now, if we take a look at NumPy load text. So if I say NumPy load txt, my file delimiter equals comma. You'll notice we have this equals, which we say here that the delimiter is equal to a comma. We don't say that for the first parameter. And that's because in functions, we have 2 types of parameters. We have positional arguments and keyword arguments. Delimiter is a keyword argument. and it has a default value. If I do not include delimiter, it will default to something else. I'm not sure what load.txt actually defaults to. We can find out probably by saying help numpy load txt. And if we scroll down, it's a bit of a mess. Delimiter. So they don't seem to say, the default is white space. So by default, numpy load text will say delimiter is equal to this. So if I was to run this, it would be no different to running this. And then, of course, the positional arguments are fixed in place. You have to have it on the first line, second line, whichever order it's in. So if we want our own functions to use positional arguments, so if I want to define offset mean again, so I have data, target, mean, value, and I want to return data minus the mean plus the target mean. So if I want target mean value to have a default parameter, I can say that target mean value is equal to 0.0. So now, if I call offset mean without specifying target mean value, it will default to 0. So if I say print offset mean, and I need some test data, so I'll say test data is numpy zeros for an array of 2 by 2. And I want to offset the mean of test data. So if I do that for a value of 3, I run into an error. I've said target mean instead of target mean value. So in the function, I have to correct that, use the correct name, re-execute that so it redefines the function, and run again. There we go. So this offsets the mean by 3. If I don't specify a target mean value, then it offsets by 0, which in this case does nothing. I can also specify target mean value is equal to 3.0. And that also works, just like we did with the delimiter in NumPy load text. And that's useful if you have multiple keyword arguments and you only want to specify a select one. If you don't specify the name, then it has to be in order. So if I say I want to create some more data, which is an array, a 2 by 2 array of 5s, then I can say data before, and I can print more data, and the data after. And if I don't specify anything, it will offset the mean to 0. So, if I was to now create a function, we aren't limited to only having one keyword argument. So I can say, I want to create a new function called display. And I want it to take 3 parameters, A, B, and C. And they have the default values of 1, 2, and 3 respectively. And this function, I want to print A, B, and C. And I need to make sure to print all three. So if I run that, create the function, and then say print with no parameters, and I call display. And then if I print with one parameter, I call display with A specified. And then I print with two, and call display with 55 and 66. So if I execute this, with no parameters, it prints 1, 2, 3, the defaults. With one parameter, it sets A to 55 and the other two are their default. And two parameters is likewise, A is 55 and then B is 66 and C is its default. If I want to specify C without setting B, I can again say C is equal to 66. And now A is 55, B is its default, and C is 66. I can also do this in any order. So I can say B is 66 and C is 55, and that also works. So now B is 66 and C is 55, sorry. So if we look again at help numpy load txt, then I actually mistakenly looked in the wrong place. But if you look at the first two lines here, this line here is what we call the function signature. This tells us what the function is expecting, and it also tells us the default values. So we can see that by default, the delimiter is actually none, which in Python means nothing. We have nothing here. So if I take the return value of a function that has no return, that will return none. In other languages, it might be called null or nan, but they all mean the same thing. It's the default value for when there's no data here. So if we look at fname, we can see it has no default value. So it's a positional argument, which is why we have to specify it as the first parameter, and we can't leave it out. So I'm going to copy some code in, and I want you to look at this and tell me which one of these two functions makes more sense.
I see what question.
Yeah.
Is it in, do you mean as like which one makes sense as in terms of reading?
Yeah, which one is more readable?
No, then the second one.
They both do the exact same thing. They just have different names.
Yeah, then the second one.
Yeah. So looking at the first one, we don't even know what the function's for. We see it's called S and it takes one parameter. But if we don't understand the maths going on here, then we'll be completely lost. We'll have no idea what's going on there. But here, immediately we see, oh, this function is for standard deviation. This is a fairly common abbreviation for it, so it's perfectly fine to expect people to know what it means. And the parameter is sample, which fairly generic name. And looking at each of the variables inside, we can see we have the sample sum here. So this part of the code is calculating the sum of the sample data. You see here we have the sample mean, so that's taking the sum and making it into a mean. And you see here, this variable is the sum of the squared deviations. So that's what this for loop is trying to calculate. And then we return the square root, which gives us the standard deviations. So it's much more clear if we use variables with proper names. If we use a equals x equals, then it's completely unclear. We have no idea what's going on. There are some cases like how we use std_dev instead of saying full standard deviation. There are some abbreviations which are by convention meaningful. So for instance, in a for loop, you might say for I in range. And in this case, I stands for index. This is a very quick way of defining the function, and you can always understand I is index. And you might also have for X in range, and then another loop for Y in range. And what that'll mean is you're iterating over an XY plane, over a 2D array. So there are some exceptions like this where it's okay to abbreviate, but where it's unclear, you should always make it clear if you can. So now we have a few more exercises, and then I think it'll be the end. So I'll put these in the Carpentries Etherpad. And then I'll give you, I'll say 8 minutes to make sure we have time to go over them. Because I'm not certain with the time zones. The workshop ends in 15 minutes, right?
Yes, that's correct.
Yeah. So I'll put these in the Etherpad. I'll give you 8 minutes to go through them. Then I'll go through the first 3 after the 8 minutes. So starting from combining strings. Okay, so that's time. I'll now go through the first 3, and then we can call it an end. So starting with combining strings. So the task is to create a function where if I run this code, it should return this. So to do this, we of course start by creating our function, calling it fence. And we see we want to take 2 parameters. So I'll call my parameters original and wrapper. And then I can return wrapper plus original plus wrapper. If I run that, create the function, and if I now print fence for name and asterisk, and there we go. It wraps the string name into asterisks. So the second exercise, return versus print. So they give us this function add, which prints the sum of the 2 numbers. And they want to know what will happen if we do this. So we say a is equal to the return of add, and we then print a. So what do you think will happen?
You're going to end up getting an error.
Okay, so you think we'll get an error? Let's see what happens.
Oh.
So it doesn't throw a stack trace error, but in theory, this could be considered a logical error. It doesn't do what we expect it to. So someone who does this might be expecting add to return the string a plus b, so they can then print it. But in fact, print doesn't have a return value. And we are also not returning anything anyway. So even if we specify here return, so if we don't specify it, it'll always return this none value, which, as I said earlier, means nothing here. We don't know what it is. If I do this, it'll still return the same, because print also is a function without a return. And so when we run this first line, it'll call add and it'll print 10. And then when we get to the second line, it'll print a, which is the return value of add. Since add doesn't have a return value, it's none. So the third exercise, selecting characters from strings, we are asked to create a function called outer, and it should return the first and last characters in a string. So to do this, we want to create our function called outer, and we want to take 1 input, which is our input string, and I want to return input string at the 0th index, the first character in the string, and then concatenate that with the last index at -1. That way, no matter what string I put in here, it'll always print the first and last values. So if I then say print outer of helium, we get HM. Okay. So that's today's workshop. I'll leave the other exercises in the Etherpad if you want to go through them in your own time. I'll also put in the answers after the workshop has ended. And if you have any questions when going through them, you can bring them up tomorrow morning when we start the next workshop.
Okay.
Okay.
Good. Thank you very, very much for your time. Much appreciated. Does anybody still have any questions, or you're all happy to? Christel, you have your hand up. Are you there, or did you go for coffee? No, he's not there. Okay, Stewart, thank you very much for your time. Much appreciated. Who will be running the course tomorrow, Stewart?
You muted you.
I think Martin will be running tomorrow.
Martin. Okay, no, that's fantastic. Okay. Thank you very much to everybody. Much appreciated. Have a wonderful afternoon, and thank you so much again to everybody for participating and to our instructors.
All right, thanks, Stuart. Thanks, Anna.
Thank you. Take good care, everyone. Stay safe. See you tomorrow.
Bye-bye.
Bye. Take care. Bye-bye. Thank you.